Alright, this is my Begriffsschrift by Frege, video number 2. This is his Begriffsschrift. It's a library book because it's kind of expensive, but I hope to purchase this one day because it's really, really interesting just to look at his axioms and even just to look at stuff like this and kind of think about it as to how it all works. And following this video, well, this video is pretty much just going to be I'm going to go over his axioms and go over his basic notation and talk about the part of this which is called some judgments of pure thought, and kind of explain how this works. Now, I did a video before this which was about the purpose of his conceptual notation, as to why he did it, and as to why it is relevant to logic today. I want to point you to videos by Chad African. He has 3 videos about his Begriffsschrift, which are pretty important and very, very helpful. And I think that he probably does a better job in those videos in kind of showing you as to how philosophically relevant this is than I do. So let's kind of get on with this here. I have some selection as to what I want to write down and kind of talk about. But what I do first have here is a couple things which these are some basic things which are on page 96. These are some combinations of the conditional stroke and the negation stroke. 8 things. So first thing I want to point out is that this is read by going from the bottom up, and it's you can't really entirely think of this as always a horseshoe, because in sentential logic we have a few connectives. We have the negation, we have the ampersand, the wedge, the horseshoe, and we have the triple bar. The triple bar he does use, but I have this here, which if we have A and B, according to Frege, that is equal to the fact that it is not the case that if A then B. And if we have A wedge B, which is A or B, we have the case that if not A, then B. So I just want to point that out, that this kind of is cool because it kind of isn't. It goes kind of beyond kind of goes beyond just the connective of the ampersand or just the connective of the horseshoe. It goes beyond that. Now, reading this can be kind of translated or thought of as according to the wedge or the ampersand or the horseshoe or even the triple bar. And as we get, as we go along in this video, I'll be kind of writing down some more complex ones and showing, I guess, the way to understand that. But I guess the way I'm going to be thinking of this as the horseshoe, I wanted to point this out, that any one thing cannot be thought of as, of course, a horseshoe or of course a ampersand, because they kind of go between that, and they can be thought of in different ways. But for the purposes of this video, I will be thinking of it usually as a horseshoe, but sometimes as a ampersand as things get more complicated. So number 1 here we have this can be thought of as if A or if B then A, because we go from the bottom upward. But Frege says this as the case not A and B is denied. Now, if we had this is the judgment stroke. Okay, this is just saying that it is asserted that if B then A, but he's kind of just not doing that for now to show that having them just like this without the judgment stroke is just saying that this is the thought that could be asserted. And these little notches here, those are negation strokes. This means not. So he's kind of like playing with the double negation, triple negation, quadruple negation throughout this little book. But he thinks of this as the case not A and B is denied. So if we had this, not A and B, like saying this is pretty much saying the denial of not A then B. But to think of it in typical terms, it's if B then A. Number two, this can be thought of as if B then not A, but he thinks of it as the case A and B is denied. A and B exclude each other. Number three, if not B then A, but he thinks of it as the case not A and not B is denied. This can be A wedge B. Number four, if not B then not A. This case A and not B is denied. He talks about affirmation and denial between negation and all that stuff. He plays with that stuff a lot. Number five. This is thought of as the case not A and B is affirmed. B and not A. 6. If B then A, because we have two negation strokes, but he thinks of it as the case A and B is affirmed, and which is pretty much the ampersand there. Number 7 is the case not A and not B is affirmed, neither A nor B. Number 8, we have two negations here, which means if not B, then A. But he thinks of it as the case A and not B is affirmed, A and not B. Okay, so now that we've done that, I want to write the axioms, which are before this. I'll find them. Where are they? Axioms. 96. Should be. 72. I apologize. This might get a little crazy, because I do want to be thorough in this video. Thorough I definitely want to be in doing this. Alright, number 1 is, we have the judgment stroke here. A. B, which can be thought of as if A, then if B, then A, or it can be thought of as A and if B, then A. Number 2. A, C, B, C, A, B, C. So this can be thought of as if C then B then A, and if C then B, and if A then C. But that's a variation, can be a variation of different things. Number 3, and this is a judgment stroke, which means that it is being asserted to that. Now these are thought of as the axioms, in that they are indubitable and they are used to prove more things. Now the reason why he had this kind of notation was to have gapless proofs and to be able to translate any kind of thoughts of any discipline into this and to do proofs with it. And this was very helpful and interesting, I think. So number 3. ABD. ADB. So I think of this as if D, then if B, then A, and if B, then if D, then A, then A. 4 is A, B, B, A. So if B, then A, then if not A, then not B. Number 5, pretty simple. That's pretty simple. I mean, that's 2 negation strokes, which means it basically means if A, then A. So it's just like saying that if we have 2 negations, that's the same thing as having none. 6 is very similar, but kind of different. If A, then not A. Again, it's a very similar thing, but it's just showing that it's kind of, what's the word, transitive. 7. C triple bar D, F of C, F of D. He uses functions, which I do like. C triple bar D, which means C if and only if D. So if C if and only if D, then if F of C, then F of D. And in the next section where he talks about sequences and how the F traits are hereditary, which I will be doing a video about hopefully today, that's very interesting. But it's kind of, this axiom is just kind of saying that, you know, if C if only if D, then if C has the trait F, then D has the trait F. Certain functions which are pretty neat. 8, which means it's pretty simple. C triple bar C, which is C if only if C. That's pretty simple and self-explanatory. 9, which is the final one, which will be introducing here the concave thing, F of C, A, F of. Now he uses the Gothic A, which I can't really do that well, but this concave thing, this little concave A in the concave line stands for generality or universality, and what that is the common way of doing it today would be this universal quantifier. It means for A, it is always the case that A has the trait F. This way of doing it is part of what revolutionized logic. And this axiom means that if it is always the case that A has the trait F, then C has the. Now this could be explained further and looked at further, but all these axioms could. But the purpose for me looking at these axioms is to show about what this notation means or is. Remember, page 141 is one that I wanted to do, bottom one. So I'm gonna just do a few things out of this book for purely the purpose of talking about what this could mean. Now that I've done the simple ones and the axioms, I'll do some more complex ones. I'm looking forward to when I do the one about sequences, which is next in the next video on Frege, I mean. A, B, C, A, C, B, C. So what could this mean, first off? We had the judgment stroke, which means that this is being asserted. And I look at it as we have three, I guess, little offshoots, I guess I would call them. Again, we're going to go upward. So what this could mean is a conjunction of this one, this one, this one, and this one. Or it could mean the conditional of the whole thing, because all these things linked up with conditionals. But we could think of this as if B then A, and if C then B then A, and if C then B, and if C then A. That's the way you could think of it. But then this could be represented in all of it linked up in conditionals. Oops. What next? Okay, yeah, we're going to do this one. This one I saw it somewhere, but I don't think I saw it in here. Okay, then B, C, C, A, C, B, A, B. This one can be thought of since it has 1, 2, 3, 4. If B then A, and if C then B, and if A then C, and if C then B. Next one. Where did my eraser go? This is the next one I want to do. 149, bottom right. A, C, B, D, E, A, B, C, D, E. That one's a little more complicated, especially because we have single ones here. So I would think that, if we had something that was more like in clumps, it would be a little easier. So that is even kind of difficult for me to even think about. So I would think it could possibly be if E then if D then if C then if B then A, and if E then if D then if B then if C then A. So this whole thing could be linked up in conditionals with ampersand linking the two. Could be that way, or it could be the entire thing linked up in ampersands. So it could be very many different things. That is why I love his notation, because it's not. It does. You can do a lot of more difficult and harder and more complex things in his notation. 156. Okay, here's one that has some negations in it. Negations. There, one there, two there, one there, and one there. Okay, B, A, B, and then B, A, B. Okay, so this one here, then this one, and then this one. If B, then A, or I mean, if not B, then A, and if not A, then B, and if not B, then A, and if not A, then B. That one is a little more complex that I like with all the negations. What else? 165. I got one more. 165. Bottom. Alright, here we go. This one has some of your concave generalities in it. Zoom. It also has some functions in it. And we have f of x, h of x, g of a, h of a, f of a, g of a. So how would this one go? I would think of this one as linked up all in a horseshoe, and then these two linked up in ampersand. And this one is, of course, horseshoe. If it is always the case that if g of a, then f of a, and then no, this one we linked up in ampersand too. I think. If it is always the case that if g of a, then f of a, and if it is always the case that if h of a, then g of a, and no, I would do horseshoe with this one. Excuse me, I don't know what I'm thinking. Then if h of x, then f of x. This is one of those things that if we're talking, that it's like inferring that if we're talking about things generally, then we can talk about things concretely. That one I think is pretty neat. I think it's cool to think about as to how we would think about that in terms of the horseshoes or the ampersands or the wedges or what. And I think it's cool to just read this stuff and think about as to what it all is going to mean or what about anything. If you think I've messed something up or done something wrong, please do let me know. After this, I'll be doing one more video on Frege's Begriffsschrift, which is about the last part, which is about the general theory of sequences and the series thing. So if you think I've messed something up or left something out, do let me know in the comments, or if you have a question as to something you found in the book or that you wanted to understand better, then also do definitely comment, because whenever you comment, I get an email. If your comment is constructive, then I will always respond.